here's what actually is happening right now. AI agents are hitting your login and sign-up pages. Some of them are your partners, your payment processors, your customer service tools, but others are attackers. And here's the problem. They look the same, technically. Let me break down what we're actually seeing in production traffic and how to help tell them apart. So there's basically three types of agents in the wild right now. First, you've got good agents that actually tell you who they are. For example, OpenAI published their IP ranges. Anthropic gives you their user agent strings. Your payment vendor says, hey, we're coming from these AWS regions. These are easy. You check the headers, verify the IPs, you're good to go. But then this is where it gets interesting. You've got good agents that don't tell you who they are. Maybe it's your customer service AI running through residential proxies because they need to geotest something. Maybe it's that new fraud tool your vendor deployed but hasn't documented, or that AI assistant marketing started using last week that nobody told you about. These look exactly like attacks. Same residential proxies, same automated browsers, same synthetic device fingerprints, all that attackers are using. And then obviously you've got bad agents, and they're getting clever. We're now seeing attackers pretending to be OpenAI crawlers. They use fake user agents, trying to get the friendlier treatment that you may want to give to good bots. So how do you identify a legitimate agent that doesn't announce itself? Good agents are pretty consistent in their behavior. Let's say a payment processor has a bot. It's going to check the same endpoints in the same order, same predictable times. Even without any information telling you who it is, that behavioral process is super clear. They also respect boundaries. Good agents follow robots.txt. They respect rate limits. They back off when you challenge them. They're trying to provide a service, not extract maximum value from your site. But here's the key thing. Good agents correlate with real business activity. When customer service AI accesses 100 accounts, guess what? Those customers actually call support. There's a paper trail. When your vendor tool logs in, you can see the corresponding API call from their integration. So yeah, the technical signatures might look like an attack, but the business context tells you what's really happening. Now, bad agents. Even the really sophisticated AI-powered ones, they have tells. The biggest one is intent leakage. They're trying to commit fraud. They're trying to make money, and it shows in the patterns. They'll test stolen credentials, but not in the same way someone who forgot their password would. They create accounts with data that's technically valid, but statistically weird, like addresses that don't match the IP location, names that don't follow generational patterns, emails from temporary domains. Then, of course, there's the optimization problem. Bad agents are trying to maximize extraction while minimizing detection. So they navigate directly to high-value endpoints, they don't browse around, they don't read your homepage. It's like someone speed running your website. Technically perfect, but not in a way that a human behaves. And here's something really interesting. When we throw novel challenges, not the standard captcha tests, but dynamically generated anti-agent challenges, bad agents fail in specific ways. Humans struggle in random other ways. They might get confused by different things. Agents struggle systematically. They fail in the same ways consistently. Oh, and when bad agents try to pretend they're OpenAI or whatever, they get a lot of details wrong. Wrong TLS fingerprint, right user agent, but headers are in the wrong order. It's like looking at a fake ID. It might fool you at first glance, but when you really look, you can see it. So here's how we actually classify this stuff at scale. First, we check against well-known signatures, published IP ranges, verified headers, authenticated API keys if possible. This catches self-identifying good agents quite quickly. Then we run behavioral cohort analysis. We use machine learning to cluster similar behaviors. Your vendor's undisclosed bot, it's going to cluster with patterns we see from other customers that are using similar vendors. Attack patterns cluster with known fraud. And then the next thing you want to do is validate it against business logic. Does the activity from the agent correlate with legitimate business effects? Or is it pure data extraction? And for the unknowns, where we're not quite sure, we deploy our adaptive challenges. Our AI generates novel puzzles. Good agents, of course, will either back off or legitimately solve them. Bad agents reveal themselves through how they attempt to interact with these experiences. Look, if you can't tell good agents from bad ones, that's going to be a problem, right? Block everything, that's not going to work. You're blocking payment processing, customer service. Allow everything, you're going to get destroyed by AI-powered attacks, right? So we're seeing companies really trying to figure this out, blurring the lines, not letting the bad actors that are more sophisticated through. I talked to one company last week, 40% of their traffic is non-human, and it's hard for them to classify what is that. They literally don't know if they're under attack or they just have great vendor integrations. And, the age-old question, is this a bot? It's not really how we think about things. Is this an agent authorized to do what it's trying to do? This isn't about detecting automation anymore. It's about classification and authorization at scale. Your good agents need to work. The bad ones need to be stopped. And the unknown ones need to kind of be sorted into either of those categories. And that's what we're building at Arkose Labs. Not just detection, but a classification engine that lets you tell your AI agents from theirs, even when they look identical. Because in the new world that we're now in, everyone who's at your front door and knowing who those people are, kind of important. Thanks, folks.